I'm going to show how to manipulate namespaces. I've prepared some sample data. This is a vector of namespaces. Every person has a name. Every person has an age. We can use this to find out which people are above 30. And we can use this to filter the people and then get their names. Effectively, a query. What are the names of the people that are above 30 years of age? What about names of people who are above 40 years of age? This didn't work. If we look at the ages, we can see that nobody's actually above 40. So we get an empty vector of namespaces. And since there's no such thing as a prototypical namespace, and certainly if it existed wouldn't have a member called name, then we fail to extract the names from here. Enter quad VGET. When we ask for a variable and it doesn't, there are no namespaces to get them from, then quad VGET will still work, though it uses a default value of the empty vector because it doesn't know what kind of data it is. In this case, that was appropriate because we're looking for names. So names of people above 40, and the result should be an empty vector of character vectors. But what if we did it for the age? That doesn't seem like an appropriate prototype for a list of ages. We can supply the prototype. That's better. The people can have children. What about all the children of all the people? What happened? Well, we can suspect that some of the people don't have any children, and we can verify that by looking at the name class of the children name in each namespace. Most of them it's 2, which is a variable, but some of them it's 0, which means it's undefined. Some people just don't have children. Again, quad VGET to the rescue. So we want to get the children variable, and if somebody doesn't have any children, then we want an empty vector of character vectors. Here are all the children of all the people, and we can use this to rectify the variable, the data. So those that have children, everything stays as it is. Those that didn't have any will now have an appropriate variable placeholder. Now it works. We can explore what's inside a namespace using quad VGET, but if we don't know what's already there, we can't give it the names. Instead, we give it the name class. So this gives us all the variables. And they're given as name value pairs. This means that we can conveniently mix this vector of name value pairs and get a table of everything that's in the namespace. We can also use a positive value, and that gives us a name list as a matrix and a list of all the values separately. That can be more convenient to work with. This is especially useful if you've had an error where quad_dmx will return a namespace with meta information about the error. Here we can get name value pairs for everything about this error and mix it into a table. And we get a nicely displayed table of all the information about our error. Let's import related data, but this time from a CSV file. We don't care about the encoding, but we want to infer the data type from what it looks like. Right, here's a table. To work with this, we might want to have every column as a separate vector, and the header, that is the names of each of the columns, separately. We can tell quad CSV to invert the table and to separate the first row as header. These are the columns, and these are the column names. To work with these conveniently, we can use quad VSET with a list of the names and the values. Now we have one variable for each column, which makes it convenient to do queries. Let's emulate working with this data as a spreadsheet. So we're going to import the data again, but this time we're just going to import the body as a matrix. These are the dimensions of the spreadsheet, which means that the row numbers are going to be from 1 to 6, and the column names are going to be A, B, and C if we use a convention of most spreadsheet editors like Excel. Now we can construct the cell names. We begin with a column name, and then we append the row name. And if we ravel this, that gives us all the cell names. The values are just the raveled body of the table. We'll create a spreadsheet namespace, and we'll use the array notation for this. So this is the array notation for an empty namespace. The video description for this video will have a link to a full video about array notation. Inside this namespace, we set these names and these values. Now we can say spreadsheet cell B4 or spreadsheet cell B1, A1, etc. When you want to create a function that takes many parameters, then instead of giving the parameters as a vector, you could give them as a namespace. The benefit is that it's much easier to skip certain parameters that you don't want to specify and rely on the default values. If you had a vector of parameters, you would have to have special placeholder values for those that you don't want to specify, and you have to remember the exact order of the parameters too. Let's create a function that counts, generates number sequences. We'll use quad.io 0 for making the mathematics easier. We need 3 variables: from value, a to value, and a step size. And we're going to get those extracted from the argument namespace using quad VGET. We want the from variable, but we want it with a default value so you can omit it of 0. So by default we start counting from 0. We want the to variable without a default value, so the user must supply this or we will error. And finally we want a step size where the default is 1. Now we're ready to implement the actual algorithm. We have an offset of the starting value. We use the step size to scale up the indices that we generate. We want an inclusive range, and then we have to figure out how many steps to take. That's it. Okay, let's try using our function. So we count to 10. Or we can count to 10 with a step size of 2. instead of a step size, we can say we want to count from 10 to 20 with a step size of 2 or without a step size. And since it's a namespace, it doesn't matter what order we give the parameters in either. We can use quad and S to merge namespaces. So here's a namespace where A is 1 and B is 2, and another namespace where B is 3 and C is 4. If we merge them, we get a new namespace. In order to see what's going on there, we can use quad VGET. So we can see that quad and S created a new namespace, and we started off by merging this namespace into it, and B became 2. And then we overrode that with a new B from the other namespace. And C, which didn't exist before, just gets copied in. We can also use quad and S to merge one namespace into another one. The effect here will be the same, but the difference is that we don't create a new namespace, we use this namespace and merge this one into it. Let's create a new count function that utilizes this. We're going to use inside the function a parameter namespace, and we're going to base this on a default namespace. So we have the defaults set up in this namespace here. Notice there's no to member because this is just the defaults. And we're going to merge the argument namespace into it. Remember that we also need quad.io to be set to 0. And we can't do that in here because it might get overwritten by the quad.io that is in the argument namespace. So after we're done with merging in the user's given choices, we also merge in a namespace that has quad.io set to 0. Now, inside the param namespace, we can write our formula. And now we can use it exactly the same way we did before. From 10 to 20.